right, so we're back for section 9.4, which is our add and subtract. I think this is tougher. So add and subtract. So we're going to start with this problem. Now remember, I need common denominators. And it's better if I have the smallest common denominator possible. So I have 6a and 9a to the third. Between these two, 6 and 9, 6 cannot become 9 if I'm multiplying by a whole number, and I don't want to multiply by a decimal. So 6 and 9 both go into 18. So 6 and 9 can both become 18. This is a and this is a to the third, so that means a to the third is common. So this is going to be my new denominator, 18a to the third. So some of the questions on the test, I might just ask you about a least common denominator, and that's all I'd be asking for in this case. So my 18a to the third is what I'm trying to make each of these denominators to be. So this one, I just need to multiply by 2. Multiplying the top and bottom by 2. So this just becomes a 2 there. This one over here, the 6a, needs to become 18. So I'm going to multiply by 3. And I'm also going to multiply by an a to the second, because then that would be an a to the third. So I'm going to do the same thing to the top. So this is going to become 15a to the second. Now that I have that, now I can add across the tops. But if you notice, these aren't like terms, so I just combine them. My dog is walking through, my older dog, and she is 15. And so she's Kirby, she's 15, and she breathes really hard because she's old. So 15a to the second plus 2, and then over 18a to the third. And we're just going to leave it that way because nothing else can happen. Nothing else can cancel here. I just combine my like terms. Now I'm going to do another addition and subtraction one where it's a little bit more complicated. So this is my next problem. So in this case, we need a common denominator, but right now the denominators aren't the same at all. So I need to find out a common denominator, but I can't like change this to a c squared minus 1, and I can't change that to 3c plus 3. So what I'm going to do is factor them first to see if I can get a common, like if there's some similarities. So I'm going to check that. So on this one, if you notice, there's a common factor of a 3. So I took a 3 out. Over here, this can factor, it's a difference of squares. So those conjugates. So c and c, I want to multiply to get -1, but add to get 0. So it's +1 minus 1. So now if you look at these two, hopefully you notice that they're actually pretty similar. This one has a c plus 1, this one has a c plus 1. Now this one has a 3 that this one doesn't have. So this one needs to get a 3. Now this one has a c minus 1 that this one doesn't have. So this one needs to get a c minus 1. So now I'm going to kind of put these together here. So I get 6c minus 6. This is a minus 3c, or just 3c, I'm just subtracting. The bottom is this kind of big nonsense here. And so the bottom is the same, and the top, I'm just going to subtract across the top. So it's 6c minus 3c is 3c minus 6 all over 3, c minus 1, and then c plus 1. Now, hopefully you notice, I probably should have given myself a little bit more room, is I can factor out a 3 here. And I'm left with c minus 2. And then I have 3, and then c minus 1, c plus 1. And then these 3's can just cancel. So I'm just left with this. So that'd be my final answer there. All right, so finally, we got 2 more examples. I don't know if I'm going to be able to fit them on here. We'll see how it goes. So 9, 5, we're solving. Now for solving rational, we need to make sure that we remember to check that the denominator does not equal 0. So that's one thing to remember. So the denominator cannot equal 0. So that's really important to remember. So I'll start with a little bit simpler one. So in this case, we have a fraction equals a fraction. This is the kind we can cross multiply on. So I have x times x minus 3 equals 18 times 3, which is going to be 54. Now in this case, this is a quadratic. So I'm going to move everything over to the one side. And I'm ready to solve. I want to multiply to get negative 54, but add to get 3. So I believe it's going to be 9 and 6. So plus 6 minus 9 will multiply to give me a negative 54, but add to give me a negative 3. So I can set each of these equal to 0 and solve. So x is negative 6, and x is also going to be 9. There's my 2 answers. Now remember, with these, we want to check to make sure that neither of them make the denominator equal 0. So negative 6 minus 3 does not equal 0, and then 9 minus 3 does not equal 0 either. So they're both good. All right, sorry to do this, but I'm going to pause one more time to go to one more set of notes because I try to keep them under 10 minutes, and I'm afraid I won't. So I'm going to pause once more and have a third video.